Okay guys, we're going to continue our study of trigonometric identities, and this time we're going to be looking at how to prove certain identities based on these two statements that we looked at in the last video. That is that tan theta is always equal to sine theta over cos theta, and sine squared theta plus cos squared theta is equal to 1. So let's think about how we can use this to prove a statement like this. We've got to show that tan x times by cos x is equal to sine x. Now this is an identity, so the equal sign isn't really appropriate. We want to say this is identically equal to sine x. And so what that means is we're not actually trying to solve this, right? We're not trying to find a value of x that satisfies this statement, because what we're saying is that all values of x satisfy this statement. Instead, what we're trying to do is we're trying to take the left-hand side here, right? And we're going to try to rearrange it in such a way that we make it look like the right-hand side. Okay, so the objective of these types of questions is to take the left-hand side and to change it so that it looks like the right-hand side. Okay, so now to do that, what I'm going to do is I'm just going to start, I'm going to write down the left-hand side. So tan x times by cos x. Okay. Now, what identity can I use there? Well, let's refresh our knowledge of the identities. We've got tan theta is equal to sine theta over cos theta, and sine squared plus cos squared is 1. Well, it's probably not going to be the second, is it? Because we don't have a sine squared or a cos squared, but we do have a tan. So why don't we replace that tan with sine divided by cos? Let's see if that will help us. So instead of tan x, we're going to rewrite that as sine x over cos x. Okay, so hopefully you can see what I've just done. I've taken that tan x, sorry about that, and I've replaced it with sine x over cos x. Okay. Well, then that's fairly easy, isn't it? Because we can see we've got sine divided by cos times by cos, then the cosines are going to cancel. And so all I'm left with is sine x. So there we go. We've just proven that identity, that if tan x times by cos x, that can be simplified to just give sine x. All right, let's try the next one. Now this looks more complicated, doesn't it? We've got cos squared over 1 minus sine minus 1 is identically equal to sine x. All right, so again, we're trying to show that it's the same thing as sine x. So what are we doing? Remember, we're not trying to solve to find x. We're trying to rearrange this left-hand side so that it looks like the right-hand side. Okay, now then, I'm going to share a trick with you. I think this makes things an awful lot simpler. Instead of writing sine x, just write s. And instead of writing cos x, just write c. Instead of writing tan x, just write t. Because the thing is, some of these identities, they can get really long and really confusing. And so sometimes if you're always writing out sine x, cos x, tan x, it makes it all bigger, more difficult to see. So we're just going to write s, c, and t. So I'm going to rewrite this as c squared over 1 minus s minus 1 is identically equal to something. Now we're going to try to simplify this. Now, which one of these identities can we use? Are we going to use tan is equal to sine over cos, or are we going to use sine squared plus cos squared is 1? Well, we don't have a tan term, do we? So we're probably not going to use that first identity. Instead, we're going to use the second one, sine squared plus cos squared is 1. So we're still new at this, so why don't we write this on the right-hand side? We're going to write that sine squared plus cos squared is identically equal to 1. So what can we use there? Well, we've got a cos squared. So why don't we rearrange our identity to get cos squared is equal to 1 minus sine squared? Okay? And if that's the case, then we can replace the cos squared here with 1 minus sine squared over 1 minus sine minus 1. Okay, so just to recap, what have I done? I've replaced the cos squared there with 1 minus sine squared. Okay, now there are a couple of different ways to do the next step, but what I'm going to try to do is I'm going to show you a trick that you're probably going to come across quite a lot. If you've got 1 minus sine squared, you can actually rewrite that as 1 minus sine times by 1 plus sine. That's a difference of 2 squares. Okay? You may have remembered that from some of your algebra. Right? So you can rewrite that as 1 minus sine times by 1 plus sine, like that. So replacing this thing here, this thing here. Okay? If you're not sure about that, you just need to remember this thing, that a squared minus b squared is equal to a plus b times by a minus b. Right, so if you've got something that looks like a squared minus b squared, then you can replace it with a plus b times a minus b. Okay, now if this is the case, then what have we got? Notice that on the numerator, we've got a 1 minus sign, and on the denominator, we've got a 1 minus sign. So we can now divide top and bottom by 1 minus sign. And so what we're left with is we are left with 1 plus sine minus 1. And of course, what's 1 plus sine minus 1? Well, it's just sine, isn't it? There we go, we've got our answer. We have shown that cos squared over 1 minus sine minus 1 is just equal to sine x. Okay? All right, now then. For some of you, that seems a bit tricky because you've got to know the trick about 1 minus sine squared, and maybe some of you are not that confident. Well, okay. I said that there were many different ways that you could do this type of question. So let's just try another way that maybe doesn't depend so much on using the tricks. So let's just get rid of that. Okay. Now, what have we got here? Here you can think of this thing as you're adding, or rather subtracting, two different expressions. And one of them is a fraction. So what we could do instead is we could treat these as fractions and just subtract them. And that means that we've got to give both the same denominator. So in other words, this term here, the negative 1, I've got to change it. So it's got a denominator of 1 minus s. So let's do that. So rewrite this as 1 minus s squared over 1 minus s minus 1 minus s over 1 minus s. Now, I've been very careful to include the bracket there, right? Because you've got to remember that this negative sign here, when multiplied by the negative s, is going to give you a positive s. Okay, so you've got to be really careful with your brackets. Okay, now if this is the case, we can combine these, can't we? So on the numerator, I'm going to have 1 minus s squared minus 1 minus minus s, that's plus s, all over 1 minus s. And I'm slightly running out of space, so I'm just gonna move over here on the right hand side. If I've got the numerator, I've got 1 minus 1, right? Can you see that? 1 minus 1. So I'm going to cancel off that there, so that disappears. The 1 minus 1 is 0. So what I'm left with is sine minus sine squared divided by 1 minus sine. Now on the numerator, we've got sine minus sine squared. Well, we can factorize that to give sine bracket 1 minus sine over 1 minus sine. Now, what have we got here? On the numerator and on the denominator, we've got 1 minus sines, right? So we can divide top and bottom by 1 minus sine, or we can cancel it, say. So what we're left with then is just sine. So a couple of different ways to do the same thing, but that's how we get our answer. Let's try another one. Question 3. We've got sine squared x is equal to, sine squared x divided by tan x cos x is identically equal to sine x. Okay, same thing. We're going to try to take the left-hand side and make it look like the right-hand side. So let's rewrite that. I've got sine squared x over tan x cos x. And I'm just going to rewrite this using the letters s, c, and t, right? So I'm going to write that as s squared over t times by c. Now, what identities can we use here? Well, first thing to notice is we've got a tan, right? And so if we've got a tan, we can immediately replace that with sine divided by cos. So let's just do that. We're going to get sine squared s squared over tan is sine upon cos by cos. I want you to see, what have I done? I've replaced the tan with sine divided by cos, which is using this first identity there. Okay. All right. Well, then on the denominator, what have I got? I've got sine divided by cos times by cos. So the cos's there, they cancel off. So what am I left with? I'm left with sine squared over sine. And so then if I do that, sine squared divided by sine is just the same thing as sine x. So actually, that is quite a simple one. And it reveals to you as well one of the potential traps, right? You could have taken this sine squared, right? And you see sine squared and you think, hang on, I'm probably going to use this identity here. Sine squared plus cos squared is identity. And I want to say that you are not wrong for thinking that, right? And if you followed that, you would also get the right answer, okay? But here we've got a tan, and it's probably easier to start by looking at the tan expression and cancelling that off first. And as it happens, in this case, we can cancel, 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 and get to our answer without even using the other identity. Okay, fourth and final one. Again, we want to show that this expression here, sine cubed plus sine times by cos squared, is identically equal to sine x. So we want to show that the left-hand side is equal to the right. So let's rewrite this again. I'm going to write this as s cubed plus s times by c squared. What can I do with that? Well, the first thing I can do, I think, is I can rearrange, so I can factorize out the s, right? So you've got a common factor of s there. So let's factorize that out. S bracket s squared plus c squared. Now, what do you notice about that? Well, s squared plus c squared is sine squared plus cos squared, isn't it? Which is the second identity. Sine squared plus cos squared is equal to 1. So therefore, instead of sine squared plus cos squared, I can rewrite this and say that that is just 1. Yeah, so I've replaced the sine squared plus cos squared with 1. And so therefore, what am I left with? I'm left with sine. Okay. All right, guys, there you go. There are 4 different examples there of how to rearrange. And there are a couple of different tricks that you can use along the way. But what I would suggest to you, number 1, is instead of writing sine, cos, tan, just use s, c, and t, because it makes it easier to visualize. And I really believe it helps you to do your algebra. Okay. Second thing, if you see a tan, immediately change it to sine divided by cos, right? So get rid of your tan straight away, change them to sine upon cos, okay? Try to rearrange as much as you can. If you see expressions that you can factorize factorize them out. And then if you see something which is sine squared or sine squared plus cos squared, then use your second identity, sine squared plus cos squared is equal to 1, to get rid of those terms. But aside from that, guys, you've just got to practice and play around with this and do several questions until you get a hang of how to do this. Right? Well, I hope that was helpful, and I will see you again next time.